So dealing with files is a risky business. It can cause problems, crash programs, and it's very easy to run into errors. Let me give you a few examples. So for example, you go to load a file, but where you think that file is, the file isn't there. It just doesn't exist. Program crashes. Can't access it, fails, problem. Or let's say, for example, you go to open a file, but another program has the exact same file already open and is modifying that file. Problem. Crash. Or let's say, for example, the user manually went into Windows somewhere and changed the name of the file. Or they moved it. Any one of these things can cause a problem when we're dealing with file input and output. So we have to have some safety precautions, a safety net. So what we do to combat this situation and make sure that our programs don't crash, which is probably the worst thing that can happen to a program. If it fails, we want it to fail gently, which means we want it to inform the user without disrupting their experience too much. So to achieve this, we use something called a try-catch block, and this is a fairly common concept in most programming languages. Some languages use a bit of a different concept, but they're all basically the same thing. So if you look on the screen here, I gave an example, an outline of what you should expect. So this is what we call the try-catch block. So we try, and inside the brackets of the try is all the code that we are attempting to do, things like reading, loading the file, and all that kind of stuff. However, if that code throws an error, and by that I mean it runs into some problem while it's trying to do its job, it throws an error, we catch that error. And we call an error an exception. Okay, in this case, this is a very specific type of exception. This is what's called an I/O exception, input-output exception. There are many different types, but what we care about right now is just the I/O exception. So we're going to do a try-catch block for the I/O exception. So we're going to try our code. If it all works out, great. The catch is never even touched. However, if it does fail, the catch is going to start working, and then we can do some code inside of here. So code to execute if the try fails, if the try breaks. So it's not actually going to crash your program anymore. It's just going to execute the code inside of here. So this might be doing things like safely closing down the file, informing the user what's going on. This e.print stack trace, that more goes towards the editor or the console, and will print out all the different program calls, all the different function calls that led up to the problem in the first place. It's very useful for debugging, not very useful for the user. So you wouldn't give that information to the user. You would give that information to the programmer. To the user, you would have to inform them in some way, saying something like, sorry, there was a problem loading your file, or something like that. Possibly, it may be possibly open, or it's broken, or missing, or something along those lines. So we use a try-catch block in order to read and write our files. So that's where we're going to focus on next. And after this, we're going to look at the code and start getting it going.